Welcome back. We're going to be doing lesson 1.4, which is the sine law. So by the end of, before we get started, just want to point out what your homework will be. Your homework will be workbook pages 9 to 12, and I posted a worksheet onto Google Classroom as well. So if you could check that out, it'll help with some extra practice questions. So the sine law. By the end of this lesson, the learning goals is you will know what sine law is, so you'll know the equation for it, when we use it, right, etc., how to apply the sine law to various angles and side lengths of non-right angle triangles. So in this situation, you don't use sine law. In a right angle triangle, that's when you use your trig ratios that we've been learning so far. This is when we have not right angle triangles, we can use the sine law. And then how to apply the sine law to different word problems. Okay, so that's our goal. So sine law is the relationship between the sides and the length of the sides and their opposite angles, right? So if I have angle A, the opposite side, angle A, the opposite side will be angle, the opposite side will be side A, so on and so forth. So when I'm drawing out triangles, like I drew this one out right here, right? You'll notice that if angle A is here, right? So this is angle A, the opposite side of it will be side A. Same goes if this is angle B over here, right? The opposite side will be side B. And last but not least, if we have angle C over here, the opposite side will be side C. So when we're labeling triangles especially, this is important to remember. The opposite side to the angle is going to be that side. So with that being said, if this was side A and I wanted to know where angle A was, it would just be the opposite angle to that side. That's important to remember, how to label certain sides of a triangle in order to do sine law, because it starts to become important when we're using this formula over here. Okay, so when we're solving sine law, it can be used to solve any acute triangle where we are given either two angles and any side, right? So say I'm given angle A and I'm given angle B and I'm given side B, right? I can use that. If I'm given, say, angle C, side C, and angle A and side B, I can use it then too. So basically with sine, or you're given two sides and an angle opposite to one of these sides. So if I was given A and C and B, and I was given angle B, I could use it. You basically need at least one side with one angle, like the corresponding values. So I either need B and side B, or I need C and side C, or I need A and side A. If I have no angles that have a corresponding side, I can't use sine law. You'd have to use cosine law, and we'll learn about that later. Okay? So that's really important for us to remember. And that's because if you look at this, right, if you look at these values, you are always going to need at least one side that completes an entire ratio in order for us to find the other sides, right, or the other angles. So for any side that you're looking for, you're just going to do A over sine A equals B over sine B, or C over sine C, right? And then the opposite, you're just going to flip it over for the angles. You're going to put the angles at the top and the side at the bottom and equate it to the other two. This seems really complicated, but when you actually start to use sine law, it just logically makes sense because of the way that you're going to solve the equation, right? So again, I would write this into your reference sheet. Really important formulas. Okay, so just moving on. We're just going to go in and try to solve these problems. It's probably the easiest way for you to learn about how to do sine law, right? So it says find the unknown side length here. You need to know what the angle is opposite of the side you want to find, right? So in this situation, we have angle A, right? And I don't know what side length A is, so I can't really do anything about it. I have angle B, but I don't know what side length B is either. I'm not really sure, right? And then I have side C, right? But I don't know what angle C is. So I'm kind of in a bind here, and I'm like, okay, I don't know anything that has a ratio. But I do know that I have 2 angles inside of this triangle. So that means I can find angle C. So let's find angle C first, right? So we need to have an angle on its opposite side. Let's find angle C. All right, so I know in order to find angle C, it's going to be angle C is equal to 180 minus 52 minus 66, right? Because all the angles just add up to 180. So that'll be 62 degrees. So I know angle C now is 62 degrees. Now I have an angle in its corresponding side, right? So now I can use that in my ratios. Let's go ahead and we want to find side A. So if we're looking for a side, I'm just going to go back up here and say, okay, I'm looking for side A and I have side C and angle C. So I'm going to use that part of my equation. So I'm going to say, okay, for side A, right, to find side A, I'm going to say A over sine A is equal to C over sine C, because I know C and I know sine C. Right? And I'm just going to put in the values that I know. I know sine A is equal to 66, right? Sine 66. I know that C is equal to 2.5, right? I know that side C or sine C is equal to sine 62, right? And now I'm just going to isolate for the A by itself. So I'm going to multiply both sides by sine 66 multiplied by sine 66. This cancels out. So I know A is equal to, let's just do that, 2.5. And I'm just going to do it all in one step. So I'm going to do 0.5 divided by sine 62. And that gives me 2.831425. And then I'm just going to multiply that by sine 66, which is going to give me about 2.58. So I know it's going to be 2.6 kilometers. 2.6 kilometers. It didn't ask me to find side B, but if I was going to find side B, I would just have to do it the same way. I would do, okay, sine C divided by sine 62, so I'd just do 2.5 divided by sine 62 is equal to now B over sine B, and then I would use sine 52 as my sine B. Okay. And just make sure you multiply the side first before you complete the trig ratio. So you just make sure that you do the 2.5 divided by 62 and then multiply it by sine 66. Okay? Okay, let's find the specific angle in this situation. So if we're finding specific angle, we just put the angle at the top, right? So let's look at what we have here. We have an acute triangle where XY, so I'm just going to draw this triangle in. I have this acute triangle, and it's going to be X, Y, Z, right? So I know X to Y is going to be 12.4 centimeters. I know that Y to Z is going to be 6.3 centimeters. And I know angle Z over here is 71 degrees. And I'm just going to go in and label my sides. So that's Z, this is Y, this is X. Right? So now I have an angle in its corresponding side. I know what angle Z is, and I know what side Z is. So that's going to be the ratio that I use. And it says to find angle X to the nearest degree. So I'm looking for angle X right here. And I actually know what the side length of X is as well. So I'm going to say, okay, since I'm looking for an angle, I'm going to say sine Z over Z, right, is equal to sine X over side x, right? So let's just go put in our value. So I know z, the angle is 71. Side z is 12.4. I know sine x is, I'm not sure yet. And I know side x is 66.3. Right, so I'm going to multiply both sides by 6.3 to just get rid of that 6.3 at the bottom. Okay, so I'm going to do sine x, cancel these out. So I'm going to do sine 71 divided by 12.4 times 6.3 is equal to, oops, just got to plug it into my calculator. Sine 71 is 0.9455 divided by 12.4 times 6.3 is 0.4803. So I'm just going to go write that in. 0.480384. Right, and if I want to get rid of the sine over here, I need to do sine inverse. So let's do the same, sine inverse over here, and let's do sine inverse of that number, is going to give me 28.7. So I'm going to write it as 29 degrees is equal to x. Right, so if I go back here, I know that my x value is 29 degrees. So I'm just going to write a therefore statement always, therefore, and that's what those 3 dots mean. It just means therefore. I don't like writing out therefore. The unknown angle is 29 degrees. And that's my answer. Cool. Now we're just going to move forward. Always get a little bit more complicated. So now here we have triangle RST, right? And so we know angle S is equal to 81. We know R is equal to 50. T is equal to 24, and it says solve for the other 2 sides. So I want to know what side T and side S are, and it says round to the nearest meter, right? First things first, when you're given something like this, always draw it out. So I have this triangle, I have R, S, T, right? And let's just go put in what I know. I know that angle S is equal to 81, right? So I put that in. Side R is equal to this side, which is 50 meters, right? And angle T is equal to 24 degrees. I know that across from T is going to be side T, across from S is going to be side S. I don't know what angle R is, but it's really easy to figure that out. The first thing you want to do is determine the angle of R, because then you'll have a side length and an angle together. Right? So let's go find angle R. Angle R is equal to 180 minus 81 minus 24, right? Because we know all of those add up to 180, which is equal to 75 degrees. So now that I have angle R, I have a ratio, right? And it's really easy to work with now, so because I can just use that ratio for everything. So let's find S first. So I'm going to say, let's use this blue pen to find side S. And I'm just going to go right side S in this blue pen. Right, so side S is equal to, since we're looking for the side, we're going to put the sides at the top. So side times sine S equals R over sine R, because that's the one that I have both values for. Right, so I'm going to say S is equal to sine of S is 81, or the angle S is 81, and then side R is equal to 50. Sine R we found was sine 75. Right, so 50 divided by sine 75. And I just want to get rid of this sine 81 over here too, right? So I'm going to multiply because I want to get the S by itself. So I'm left with S is equal to, so 50 divided by sine 75 was like 51.76380902, right? And I just like to go in and do the multiplication next step right away and multiply it by sine 81. So I was left with 51.12. So it says to the nearest meter, so I'm going to leave it to 51 meters. And then I don't have to do anything else. So it's 51 meters. And we'll use orange to do T. And we're going to do the same thing. Always use your original side. So try to just continue to use R. You could, in theory, use sine S to find sine T. Or sorry, you could use side S to find side T. But I wouldn't recommend that. And the reason I don't recommend that is because you know for certain that side R is 50. And you also know with pretty much clarity that angle R is 75. Because those were the ones that were given to you. They were the ones that you did the least steps to get to. So they're least likely to be wrong. So use those values. Okay? Just to like minimize error in case you made a mistake. Okay. So we have side T divided by sine T is equal to, and sorry, this should be large capital T, sine T over R sine capital R, right? So then I have T divided by sine, and I know that angle T is 24, over, and I know that R is 50, and sine R is sine 75. Right, so I'm just going to multiply both sides by sine 24 to get rid of that sine 24 at the bottom. So I'm just going to do, okay, 50 divided by sine 75 times sine 24. T is equal to 21.05, so I'm just going to leave it as 21. So T is equal to 21 meters. And I like to always write out my equation or like my therefore statement. So therefore, and I like to fill out the triangle always as well. Therefore, for triangle RST, angle R is equal to 75 degrees, S is equal to 51 meters, and T is equal to 21 meters. And that'll be your statement for this. Okay? The trickiest part is usually the drawing. All right, and obviously we're going to do a word problem and then we're going to be finished. So for this one, it says that Asher wants to make a triangular garden in his backyard. There is an 83-meter portion of fence that he would like to use to make the garden. He also finds a 110-meter piece of wood. He needs a third plank, plank of wood, and he notices that when he measures the angle it would have to make with the wall, it's about 74 degrees. So first draw a diagram, and then determine the length of the missing piece and the rest of the angles in the garden. So first things first, let's draw what we know. We know that he needs to draw a triangular garden. So I know that there's this 83, let's say the wall is here. Right, so let's say the wall is here, and that's 83 meters, right? And then he finds a 110-meter piece of wood and he joins it with it. So let's say this is 110 meters. This last piece of wood that we're looking for, that'll be like right here, right? And I'm sorry, I'm just drawing in my triangle so that it looks a little bit nicer, right? We don't know what this last piece of wood's going to be, but we know it's going to make a triangle. And we also know that the angle that it makes with the wall is going to be 74. Right? So I'm just going to go in and label this. I'm going to say A, B, and C, right? So that I have values that I can work with. So I'm just going to say, okay, this is A, this is C, and then this is B. So essentially, I'm looking for what is side B, and what is angle B, and what is angle C. I already have angle A, and I have side A, so I can use that to my advantage, right? So I can say, okay, if I want to find out what angle C is, I have side C, so maybe that's the first one I should go look for, right? So I have side C, I have angle C. For B, I don't have anything, so I can't really do anything about it right now. So let's just go find angle C, and maybe I can do something with that. So I'm going to use sine A over A is equal to sine C, which I don't know, over side C, which I do know. So sine A is 74 divided by 110, which is what side A is, right? And so sine C, I don't know what that is. And the length of C is going to be 83, right? So I'm just going to multiply both sides by 83 just to get rid of that 83 at the bottom there. So I'm left with sine 74 divided by 110 times 83. So I'm left with 0.72532 is equal to, it's like a way longer, but that's okay, is equal to sine C, right? And now I want to get rid of that sine, right? So I'm going to do inverse sine, and whatever I do to one side, I do to the other. So I'm going to do inverse sine of this number. So I'm just going to plug that into my calculator. So I'm left with 46.5. And since it says we like to just keep them to the nearest whole number, we'll leave it at 47 is equal to side C, or angle C, sorry. So let's just go put that in. Now I know what angle C is. I know what side C is. I still don't know anything about B at all. I don't know what angle B is. I don't know what side B is. And I want to find out what side B is. So looking at what I know, can I find angle B? Yeah, I can. The reason I can find angle B is I have these two angles, right? So now angle B is a little bit easier to find. So I'm going to say angle B is equal to 180 minus 74 minus 47, right? So 180 minus 74 minus 80 minus 47 is going to give me 59. And now that I have angle B, and I have side A, and I have angle C, angle A, I now have enough information to find out what side B is, right? Because I have enough of that ratio. So let's find side B. And in order to find side B, I'm going to do the same thing. I'm going to say, okay, A over sine A is equal to B over sine B, right? And let's just go in and put our numbers. So I know side A is equal to 110, sine A is sine 74, equals B, which I don't know, over sine 59, because I know angle B is 59. Going to multiply both sides by sine 59. So let's just do that. 110 divided by sine 74 times sine 59 is equal to 98.08. So I'm just going to leave it as 98.1 is equal to B. So I know that side B over here is going to be 98.1 meters. So obviously going to write my therefore statement. Therefore, Asher must buy a 98.1 meter plank, and angle B is equal to 59 degrees, and angle C is equal to 47 degrees. And that will be your statement. And that's it. That's it for this lesson. make sure you go through and understand how we did all of these. Sine law is a little bit easier because it's just ratios, right? So if you know one angle and you know one side, you can use that ratio to find the rest of them. The part where you need to think about it is if you don't know the angle or the side of something, then it's a little bit harder and you have to figure out a way to figure that out. Okay? So that is it for SineLaw. Your questions are in the workbook pages 9 to 12, all the questions plus the worksheet that I've posted. Thank you.